release. Let's go over here and talk to James Cooper. You're going to show us what's going on there.
Yeah. Hi. So I have here an example of a non-explosive actuator. We have 178 of these.
These are all these little pins we're talking about, right?
James Webb, right?
Yeah.
107 of the 178 are the membrane release devices. And we use this type of actuator because it produces a very low shock when it's released. And the animation shows conceptually how it works. We send an electrical signal through either one of our connectors. We use both, but either one of them can cause the release to happen. It melts a small wire inside, and then we have a spring that unwinds and allows two halves of a split nut to separate, and then our pin can get extracted. And so in the case of the MRDs, it's a spring-loaded pin that pulls to release the folded membranes. In other places, we would be bolting two pieces of structure together and then releasing them so we can deploy them.
And the sun shield itself has 107 of these?
107 MRDs that all have to work.
Every single one has to work.
Every single one has to work.
Discovery,
and 178 of this type of device in various configurations around the entire observatory.
Right. Well, if we go over here, we've got something sort of lovely waiting for us, a big gold hexagon. So tell us what we're looking at, a sort of a model here of the mirror segment, right?
Right.
Yeah.
Full-scale, single segment, one of the 18 mirror segments on James Webb. The real ones would be machined out of a single piece of beryllium to the exact curvature we need. And then once we're deployed on orbit, each segment can be individually focused to make it act as a single perfect mirror.
Now that coating, tell us about this gold coating here.
Yeah, so this is coated with a very thin layer of gold. It's only a few hundred atoms thick of gold, and that gold is really good because it gives us a reflective property in the infrared, and that's really what Webb is an infrared telescope, and we need that sun shield exists to cool this entire telescope. So this mirror actually runs about minus 400 degrees Fahrenheit on orbit. If it were warmer than that, the infrared energy coming off of this, that heat energy would swamp our detector system and our instruments. So that entire sun shield exists to cool all 18 of these down. And again, this gold coating is what helps with all that reflectivity to make it perform even better.
Well, that's wonderful. So you put it all together, and we have a smaller mock-up here, the sun shield, the mirror. Tell us what we're looking at here.
Much smaller. So, yeah, this is our entire observatory fully deployed on orbit. And you can see the sun shield here is a large feature. You can see all 5 layers that I talked about earlier. And it's the separation of those 5 layers which lets heat energy escape out to space before it eventually gets to this cold layer. Again, that entire telescope is running minus 400 degrees Fahrenheit, and the way we get it that cold is this side is shaded. The telescope is looking to the deep universe, which is near absolute zero. And then again, this layer here, we've got about a 500-degree temperature drop, so this telescope is also looking at this layer here, which is nice and cold. So that's what lets us, harness thermal physics to cool this down to those really, really cold temperatures. Again, you can see our booms, which are fully deployed and stretching this out, and then ultimately it all folds up and gets stowed into this structure for launch.
Right, so the membrane release devices would be along the back side of these structures on the forward and the aft side. And we release them in rows so that we can sequentially start to unfold the membrane once those pins are pulled out of the way.
Well, that's wonderful. Thank you so much for joining us, and best of luck on the launch. I'm very excited.
Yeah, thank you.
Discovery, go at throttle up.
Okay, let's get a live launch status update from NASA commentator Rob Navies at the launch site. Rob, how are things in Kourou?
Well, thank you, Michelle, and Merry Christmas from the Jupiter Control Center here in Kourou, French Guiana. You are looking live at an Ariane 5 rocket on its launch pad, ready to send the James Webb Space Telescope on the initial phase of its journey. The fueling of the Ariane 5's first and upper stages began before sunrise, and in the last few minutes, mission controllers here in Kourou and at the telescope's control center at the Space Telescope Science Institute in Baltimore conducted polls, with all positions reporting they are go to proceed into the final phase of the countdown. Launch controllers have been monitoring weather conditions throughout the night, keeping tabs on clouds and wind speeds, both at ground level and in the flight path of the Ariane 5, ensuring that all of the precise commit criteria are acceptable for launch. Right now, we have a green board, no issues as the countdown proceeds, no issues again being tracked by the flight control team here in Kourou. By the way, our broadcast today is a collaborative effort between NASA and the European Space Agency. So that's it from now. From the Ariane 5 Mission Control here in Kourou, we'll be back with you soon. For now, let's go back to the Goddard Space Flight Center and Michelle Fowler.
Thank you very much, Rob. So Webb asks big science questions. It demonstrates astounding technology. It inspires and excites people to dream and wonder. And the spark of inspiration is the ignition of creativity. Kids all over the world have a natural affinity for Webb's big pursuits. And now we have a collection of young artists ready to showcase their work.
Hi everyone, I'm Kelly Girardi, and this is Delta V, and we're kicking off the Unfold the Universe Challenge with NASA and the James Webb Space Telescope. NASA is hosting an Unfold the Universe Art Challenge. Use your imagination to share what you believe the Webb Telescope will find.
Discovery, go at throttle up.
I believe that the Webb's telescope will see galaxies, stars, planets, the moon, and don't forget our star, the sun.
Discovery, go at throttle up. Discovery, go at throttle up.
Up in the sky, really high.
Discovery, go at throttle up.
Space.
Ooh, space. Thanks, Greta. Good job.
This is my picture of space. Hello, my name is Gabriel. I am from Romania. This is how I imagine space.
Hello everyone, good morning. This is a drawing of distant galaxy that can be seen by James Webb Space Telescope.
Hi, my name is Anastasia, and this is what I drew when I think the telescope will look like, what the telescope will see. I drew the Earth, the Sun, a new planet, a black hole, and stars.
So we've been fielding social media questions from viewers all over the world this morning, and let's take a couple of minutes to share some responses. There's been a couple questions about how long will it take for images to come out, and there's a lot of things that need to happen before the images are coming. So Macarena, why don't you take us through some of that?
Yes, so for the first scientific, beautiful images to share with the public, that will take 6 months. And the reason is because it is, so we launched today. It takes a month to take to the orbit place, to the Lagrange 2 point, and then we have a whole period of cooling down the instruments, aligning the mirrors, and making sure that all the instruments are ready to do science. So the whole process takes 6 months, half a year.
And also all of those 18 segments of mirrors, something needs to happen to get them all working together too, right?
Exactly, because initially you launch with 18 segments and they work separately. So you will take, if you observe one star, you will get 18 little points. So there has to be a process where you take images with NIRCam, which is one of the cameras on board, start moving the mirrors slightly to make them work as a single one, and then by the end of this iterative process, you go from 18 points to a very sharp, pristine single point source. So all mirrors act as a single one.
So let's see, we have a question from LV coming in on Twitter. Will Webb be able to enhance detection of comets, asteroids, or meteors that enter our solar system? So that seems we've got a planetary person there.
Sure. Yeah, well, Webb does have a special observing mode where it's able to track these rapidly moving objects, because compared to these distant stars and galaxies, asteroids and comets, they move pretty quickly. And so Webb will be able to do this so that we can study material that's outgassing from them and learn more about what they're made of.
So let's see, there's just so many good questions, so we only have time for a few more. So one is from Kristen Rodriguez on Facebook. How long will it take James Webb to reach Lagrange point 2? And you might also just explain, what is Lagrange point 2?
So it takes a month. I think it's actually 29 days to get there. And the Lagrange 2 point is this very interesting stable point. So the gravitational pull between the sun and the Earth create this point where it is stable, and you can, as we can see there, Webb can orbit around the L2 point in a very stable orbit, only needs a little bit of corrections once in a while. And it can always have the sun shield protecting the telescope from the radiation of the sun. In a year, in a full year, you can observe any object in the sky, and it's a continuous observation.
Well, thank you very much. We'll hopefully come back to a few more questions later.
Thank you.
So this is a big mission with a cast of thousands to bring it to life all over the world. As we get closer to launch, let's take a brief look at the main locations where Webb took shape on its journey to space.
Inside the massive high bay clean room at NASA's Goddard Space Flight Center, engineers assembled the 18 gold-covered mirror segments into the backplane of the telescope and integrated the 4 science instruments contributed by international partners. To simulate the harsh environment of launch, they went through vibration tests and acoustic tests. And to simulate a space environment, the instruments endured cryogenic testing in a large thermal vacuum chamber. But it wasn't large enough to hold both the instruments and the mirrors, so the telescope boarded a plane to Houston, Texas, to visit the only thermal vacuum chamber in the world big enough to fit the entire assembly. Chamber A at the Johnson Space Center was originally built to test the Apollo spacecraft, and half a century later, it provided a grueling 100-day test for the Webb telescope. Next, the telescope traveled to Northrop Grumman's facilities in Redondo Beach, California to meet up with its other half, the Sun Shield and spacecraft bus. Fully assembled at last, the entire observatory went through yet more tests. Many focused on making sure the spacecraft could properly fold up for launch and unfold in space. Then in September 2021, Webb caught a ride on a specialized cargo ship and set out on a 16-day voyage to the European Space Agency's spaceport in Kourou, French Guiana. According to its travel itinerary, that's Webb's last port of call on Earth.
Once Webb gets into space, we're going to have some exciting things to tell you about what happens next, from its extraordinary engineering to the thrilling scientific adventure it's about to enable us to undertake. But launch comes first. And for that, I'm going to turn it over to Katie Haswell, our host at the launch site, and one of NASA's most recognizable voices, launch commentator Rob Navies. It's all yours, Katie.
Thanks very much indeed, Michelle. Well, it's all looking very good here at the spaceport for a Christmas Day launch. Operations running smoothly, the countdown ticking over nicely. All the systems are green and we are go for launch. You can see there we're looking at launch pad number 3, the James Webb Space Telescope, inside the very top of the rocket in first class with its seatbelt on, waiting patiently for liftoff. That's scheduled in about 32 minutes' time. I'm in the Mission Control Center here at the spaceport, the nerve center of operations. We're about 10 kilometers from that pad, and behind me you can see it's a laser focus here in the control center with the mission control centers all on console there as we get closer to launch. We call this the fishbowl behind this protected glass. And up in their skybox here in Mission Control are NASA's Rob Navies and the European Space Agency's Luce Fabregat, and they're standing by to take over the commentary about 15 minutes as we get closer to launch. First of all, though, let's check in on the countdown and let's see how things are progressing with Stefan Israel. Stefan is the CEO of Ariane Space. Ariane Space is the company responsible for getting our telescope into space today. Stefan, thanks for joining us. No pressure.
Good morning, Katie.
How are things looking?
So we are now 31 minutes before liftoff. So far, so good. Ariane 5 is ready. Webb is ready. The range is ready. And the weather is green.
Well, that's good to hear. So what can we expect to see? What's going to happen?
Yes, so in the 30 coming minutes, we will make the final operations. 10 minutes before liftoff, we will have the final authorization of the weather. And 7 minutes before liftoff, we will enter in the famous synchronized sequence.
And, I mean, how's everyone feeling? I'm guessing everyone's...
We launched for humanity this morning from the Guyana Space Center. You know what Webb is about? After Webb, we will never see the skies in quite the same way.
It's an important project, isn't it, for everybody?
It's a very special mission, but we have delivered already 111 times with Ariane. This is the 112th Ariane 5, so we will deliver this morning.
And everybody there in the control center, cool, calm, and collected. Stefan, thank you very much for having taken time to step out of the fishbowl for us. So you can head back now into the fishbowl and take up your position. Stefan Israel, thank you very much indeed. Stefan, of course, heads up what we call the flight desk, which is the authority that takes all the final decisions in the event of unplanned situations. Now, we are in French Guiana. We're on the northeastern coast of South America. We're in Amazonia. It's hot. It can get a little bit sweaty sometimes, and there are lots and lots of mosquitoes. But somebody who knows it very, very well is Raphael Chevrier. Raphael is a rocket scientist, or a rocket expert at least, from Ariane Space. Thanks for joining us, Raphael. Tell us a little bit more about French Guiana.
Well, French Guiana is a French territory that borders Brazil. It's located in the Amazon rainforest. 97% of the land is covered in trees, so that's why it's so green and beautiful. And you can totally imagine that the wildlife there is absolutely incredible. This is actually one of the best preserved habitats in the world.
And of course, it is in the jungle, and yet it is actually the European spaceport. So what makes this location in South America so important and so relevant?
Well, there are several reasons for this. First, we are on the coast. It means that we can launch over the sea from north to east without having to fly over inhabited areas. So this is very convenient to reach any kind of orbit. There is no hurricane here, big tropical storm, there is no earthquake, but more importantly, we are very close to the equator, so that we can benefit from what we call the slingshot effect given by the rotation of the Earth. So let me take this globe. Basically, here on the equator, we are all traveling at roughly 1,000 miles per hour. That's very convenient. Of course, we don't feel it. If we were on the poles, that speed would be very, very close to zero. It means that when Webb is right now on the launch pad, inside the frame of the Ariane 5, it's already traveling in the right direction, and we can use this extra boost to get us into space. That's also very convenient for Webb, because doing so, it can save its fuel and increase its operational life in orbit at 1.5 million kilometers from here.
And that really is important, 1 million miles, isn't it? And so there's a real proper slingshot effect. Yeah. And the facilities here are ultra high-tech, and that's exactly what Webb needs, isn't it?
Yeah, that's very convenient for Webb. It's also located in a nature reserve. So this is the perfect meeting between nature and technology, and people come from all over the world to work here. But one thing that's been very important for Webb is cleanliness, because you know that one speck of dust could alter the vision of the observatory in space. That's why we have been extremely careful in keeping a pristine environment in all our facilities, from Webb's arrival in French Guiana to sealing it inside the rocket.
So let's talk a little bit now about the Webb Space Telescope. I really don't think you need me to tell you that it is the product of a feat of human ingenuity. And you don't get to make a telescope as complex as the James Webb Telescope and as remarkable without tremendous amount of collaboration. And the James Webb Space Telescope is indeed the product of a partnership between 3 space agencies who came together to create it. NASA, the European Space Agency, and also the Canadian Space Agency. So here to talk about that now is Greg Robinson from NASA. Greg, thank you very much for coming to the floor, out of the fishbowl as well for us. And we're talking serious teamwork here, aren't we?
Yes, Katie. We've benefited from an amazing partnership with the Canadian Space Agency and the European Space Agency. Over the life of the development, we've had more than 10,000 people actually touch Webb, 29 states in the U.S. and 14 countries across the globe, and not to mention the amazing industrial base across the globe that have benefited here. In order to do bold missions like this, it takes lots of resources and lots of expertise, so we maximize everyone's expertise.
And how did this bold mission get onto an Ariane 5 European launcher?
So as part of the partnership, the Canadian Space Agency contributed science instruments, and they're incredibly important for this mission. And so did ESA. Science instruments and the amazing Ariane 5 that we will see take us on this journey and put us in the right direction to get to Lagrange Point 2. And we're looking forward to that.
It's a tremendous atmosphere here, isn't it, in the Mission Control Center? There's a real buzz here today. I wonder how you must be feeling, Greg. I mean, it's got to be a very, very emotional time knowing that your telescope is sitting there on top of the rocket, getting closer to launch.
It's certainly amazing. Often talk about the butterflies, and people keep asking me, have they started? Have they started? And yes, they're starting. And when we get to about 20 minutes out, they will start flying a lot. So
well,
the excitement is just amazing.
The excitement is building, and of course everyone very cool, calm and collected. Thank you, Greg Robinson. You can take your position back in the fishbowl now, because I know you've got a lot of work to do in there. Greg Robinson, thank you very much indeed for joining us. So the Ariane 5 launch vehicle is the heaviest lifter in the Ariane 5 Ariane family of launchers. And Raphael, she has got an incredible track record, hasn't she, of success?
Yeah, this is a very reliable and successful rocket. Webb is going to be the 112th Ariane 5 to be launched. And the very first Ariane, the Ariane 1, took off exactly 42 years ago. Yesterday, this was on Christmas Eve, 1979. Good symbol.
Yeah, and hopefully we're going to get a good Christmas present today as well. And, I mean, the rocket is also, you don't get to build a rocket like this without collaboration either, do you?
Of course, just like Webb, actually. In fact, 12 different countries have been participating in the development of the Ariane 5, with Ariane Group now being the industrial prime.
And we have a scale model right next to you, Raphael. Why don't you talk us through it? The rocket is made of sections, and we often call those stages, which is what you might hear during the commentary.
Exactly. So first you have the two boosters, solid boosters, that are located on each side of the rocket. They will provide the main thrust in order to literally push the rocket against the gravity of the Earth. Then you have these big tanks that form the main cryogenic stage, with the main engine Vulcan at the bottom.
And then you have the Webb telescope right at the top, inside the fairing.
It is right there on the launch pad, and together they are put on top of the third stage, a cryogenic stage, and it is this upper stage that is going to place Webb into orbit.
And what about the engines? What are we going to see at liftoff?
At liftoff, we first see the main Vulcan engine ignite first. We do this because we want to check it's working properly before we switch on the solid boosters 7 seconds later. Once it's done, there is no turning back. The rocket is going to lift off. And so, yeah, that's very, don't be surprised. Don't be surprised.
Hey, chat, does this work? Oh my god, it works.
Let me figure if I can try.
You want to try? Okay, all right.
Discovery, go at throttle up.
Ready?
Oh my God, this is the most janky way to do this. You have no idea. Oh my God.
Discovery, go and throttle up.
All right.
So now what Das was saying was to capture
What?
Well,
No, you know what? This is working. Let's just roll with it like this.
okay, so if you have your video on, it's not going to match up with the audio they're hearing.
There's no way. We're gonna get super desync. All right, here, let's see. Ready? Test. Oh.
Maybe you should turn it off and just...
That's terrible. That's so bad. It's like a kung fu movie. Oh my God. All right, let's put them back on.
It's already started that journey because it's traveled to the launch pad from Los Angeles.
It works.
After
that works,
final
man.
tests were concluded in Los Angeles,
but it works.
Webb was packed into a special container and transported along the LA 405 freeway, which had to be closed because it's so big.
Merry Christmas, everybody. What did you do to get it to work?
It traveled on a special ship.
Idea.
A lot of
this is Das's idea. We have a Discord call going between Brimo's phone
by plane,
and the computer.
But Webb was too big for that, so it had to travel by ship, and it went through the Panama Canal.
I don't know, man. It's working though, so it's fine.
Up through the locks.
Dude, I don't know, man. Whatever. It's working. So
it took 16 days.
Dude,
to get to the port.
The computer went completely DOA. No microphones detected.
Where it was
no audio inputs detected. 3.5 USB.
Traveled to the spaceport.
Driver update. Restart.
That's not the real Ariane 5. That's the model.
Something is broken.
Just outside
or
the Jupiter
Windows
Control
changed the
Center,
setting that I don't know. I'm just too tired to go and find.
It was unpacked very carefully in the facilities that Raphael was talking about.
Is the phone charged? I can plug it in.
And then fueling started, and of course...
Yeah, I should plug it in right now.
The teams had to wear special suits because that's
there we go.
A dangerous job. And then it was placed all the way on top of the Ariane 5 rocket.
It's okay. The delay isn't too bad. Dude, hey, you know what? It works.
It was encapsulated inside the fairing and sealed. And then it was rolled out to the launch pad 2 days ago. From the vehicle assembly building to the pad along very special rails. Very, very slow. Through the Amazon rainforest. It was raining at the time. And that was 2 days ago, and here we are now.
That shot of it raining on the rocket.
17 minutes,
I don't like
46 seconds to launch, and counting. All systems are go here at the European Spaceport in French Guiana. We have 3 control centers on the job today. We have the Mission Control Center here.
Yeah,
we also
I'm in
have
Detroit.
the Launch Control Center, which is about a mile from the pad.
With
and then we
terrible
also
audio
have
delay.
the
It's designed to be
Telescope
rained
Control
on.
Center, Mission Control in
bet it
Baltimore
is.
in the US, and that's where the operational teams are standing by to take over the telescope operations.
Here.
Once it's
You'll
released
know
from
I'm
the
in
mothership,
Michigan because
that
of
will
this.
be about
tell I'm in
27
Michigan
minutes
because of the way it
after
is.
launch. And they'll be controlling the Webb telescope for the rest of its life. Very important job.
What's up, WD? Do I look like I know
James
what a
Webb
JPEG
Space
is, boy?
Telescope is a truly remarkable observatory. People have been working on it for over 2 decades. Some people have been working on it for their whole professional lives. Thomas Zurbuchen is the head of science at NASA.
Nice.
And
now we're good.
he's joining me now
Thanks,
just to
thanks
talk
for the
about
raid,
it.
man.
Thomas, I mean, or Dr. Z, as we can also call you.
Oh, well, thank
the day
you,
has come.
Katie. I just want to
All
say
these
how
decades,
good of a
all
launch
this time,
this is.
all these people working on the telescope, and here we are, 16 minutes and
more right
counting
here.
to launch. It's a big day, huh?
Oh, I'm so amazed, right? We have this telescope on top of this rocket, a telescope that 10,000 plus people have worked on in many ways, and together with that telescope, all the hopes and dreams of those individuals, and also tens of thousands of scientists, some of them not even born, that will benefit from these data, are there with them, waiting for these last minutes of countdown for its journey to space.
I'm guessing people are feeling a combination of emotional excitement.
What the hell
What's going
was
through
that?
people's minds, do you think?
Oh, I think there's a tremendous sense of accomplishment. Whenever
It's
you're
gone
on top of the
plaid.
rocket, many things went really, really well. There's tremendous pride. There's
Jeez,
always a little bit of
thank you very
anxiety.
much.
We know launching is hard. We have one of the
was
absolute
50.
best teams in the world working on this right now, so I'm
It's too
confident in
early
that.
for this, man.
We're super excited. I mean, I just an amazing day.
That is
today.
Gunther Steiner,
And what
yeah.
are you most excited about,
Yeah.
Dr. Z?
Well,
you know,
I'm a
if the launches
scientist,
that
but
are
for
going
me,
to look like rock
besides
stars.
the technology, that really is a marvel. I mean, it's really the best we can do. What I'm thinking about is really looking at the universe in new light. We have never seen the universe how Webb will show it to us. And can you just imagine going back in time, 13.5 billion years? It
Well, we don't talk
boggles
about
your
that
mind,
part.
even as a professional astrophysicist. Kind of just think about all the new
Kind
things
of
we're going to
nuggets,
learn
yeah.
about our most beautiful universe.
Dr. Z, thank you very, very much for joining us. And I want to wish you and all the teams, everybody, the very best for today's launch. Thank you.
Go Webb.
So, yes, indeed, go Webb. So we are now 14 minutes and 30 seconds to launch. We're getting really close now. Everything's going well. All systems are green for launch.
25,
And I'm going to hand you over now to NASA's Rob Navies in the skybox alongside the European Space Agency's Luce Fabricet, who are going to take on the commentary from here on in. Over to you guys. Rob.
Okay,
Well, thank you,
14
Katie.
minutes.
Merry Christmas to our worldwide audience
You too,
from our
Forge.
broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabricet, the head of infrastructure and value chain for the European Space Agency. Luce, good morning. It's great to be with
It's
you.
not
Great to
ideal,
be with
Alexis,
you
but we're
today.
making it work.
Very pleased to be
The-
here with
the
you
desync
and
is
all of you
terrible.
watching us for this very
But hey,
special event.
it works, so.
Well, at this hour, countdown clocks are ticking backward. We are at T-minus 13 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds
Getting
fool
nervous?
you. We are
Nah,
go for
good,
launch.
man.
The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control
There's
center.
no problems
and
here.
everything has gone extremely smoothly in the countdown.
Chris,
About
give
9
them
minutes
some
ago,
M&M. Thanks,
a major
Chris.
milestone passed
Thanks, guys.
as the James
I
Webb
really
Space
appreciate it.
Telescope began the process and completed the process
I ain't nervous,
of
dude.
receiving
Are you
commands
nervous? I was
to
more worried about my
transition
streaming
from
setup.
external power to internal battery
Another
power
one, Chris?
following the latest
Another
in
one.
the series of those weather briefings. Webb will remain on internal battery power until its singular solar array unfurls
that's
about
right.
30 minutes after launch. Earlier, telescope controllers reported good environmental readings from sensors inside
good
the
to me,
fairing, encapsulating the
I've said that
telescope
many
atop the
times.
upper stage of the
Hey, Meth,
Ariane
what's going on?
5 rocket. And Luce, as we enter the most critical phase of the countdown, can you outline some of the upcoming critical activities as we head into the phase called synchronized sequence?
Yes, Rob. We are now reaching the end of this 11-hour sequence that we call the chronology, and that started yesterday evening. All systems
It's fine,
here
Jonas.
have been prepared for
I told
final
you
launch
guys,
operations.
look, there's a lot of things that can go
Time
wrong,
being, it's
but
quite, it's
it's
rather
all
quiet
single
now
fault redundant,
inside
which
the
doesn't
launch table
necessarily
and
mean
also
don't
inside
you
the
don't have a
launcher.
backup.
We were told a few minutes
A
ago by
toilet
the
flusher
launch
doesn't
control
have a
center
backup.
here
It's single
that the
redundant.
launcher fluids and
Because
electric
it's simple.
systems are ready for the final
You know,
automated
like,
sequence.
you flush the
They
toilet,
are
it's
on
not
hold
like you have
now,
two handles,
waiting
you know
for
what
the
I mean?
last weather report
Some of
at
it's
minus 10 minutes.
single redundant because it doesn't need
After
to be
this
more
weather
complicated.
report,
It's an important thing to
3 minutes
understand.
later, we will have the beginning of this famous synchronized sequence when all
It's going to
systems
take about a month
will
to
be
get out
made
there,
ready
Zombie, from what I
for the
understand.
liftoff.
I think that's what they said.
This sequence will first be read
Morning.
by the ground calculator,
Spark,
And
tier
then
2, 10 months.
the
Thanks, man.
onboard computer will take the lead step by step. And
Isn't that a great
the launch
example? Your
vehicle
toilet breaks all
will
the
be
time.
made
Well,
autonomous from the ground
Put
system.
your toilet in a clean room and build it that
You know
way.
that we have 2 tanks in each
Space
cryogenic
toilets,
stage,
man.
upper stage and main stage. All 4 tanks are, of course, thermally insulated from the hot environment we have here in French Guiana. However, these liquid propellants are at very low temperature and because of that, slightly evaporate.
First gifted another sub
And to ensure they are perfectly loaded at liftoff, their final loading and topping up
Well, passing,
will
we don't
last
need to
up
worry
to
because
4
James Webb
minutes
doesn't have a
before
toilet
launch.
on it.
So that will be the beginning of
Obviously.
the synchronized sequence run by the ground
No
calculators.
way, Zombie. Let me see.
Then we will have on the
No.
fleet side
Where?
the end of the topping up, the final loading and the topping up of the different tanks. And on the electrical side, we will have the onboard computer getting prepared for the launch also, and it will be uploaded
How
with
bad
the
is the
H0
desync?
with the H0 time,
Cast.
the time for the liftoff, which is today
Hold on.
9
we'll
beginning
try
of
to
the
sync it.
window,
We'll try to sync it. Hold
9:20
on.
local time, 7:20 Eastern time.
Hold on.
Discovery, go at throttle up.
And Luce, we're coming up on that final weather report. We expect all systems to remain green.
Dude,
we'll be going
actually,
down
yeah, I
to the
think I'm
fifth
just
bolt.
gonna let it roll.
Confirm that just a moment or
Let
two
it
from
roll.
now. It's a 27-minute ride to orbit from liftoff until the time that the Webb Observatory is separated from the upper stage of the Ariane 5 rocket.
I don't wanna
Several
mess with
minutes
this right
later,
now.
the
It's too
commands
early.
will be given to unfurl its solar array, followed by the confirmation from the telescope controllers in Baltimore.
It
that,
is about
we are
1.5
power
seconds.
positive,
If
meaning
I could just
that
remember where the
electrical
damn
current is flowing
the
through that
webcam
solar array.
settings are.
With us
I don't-
today,
I
inside
don't
the
wanna break
so-called
something.
fishbowl, seated with mission controllers on
like
the
doing
floor
open
of
heart
the control
surgery,
room
man.
is Raphael Chevrier
Troubleshooting
of
while
Ariane
streaming is
Space.
a no-no.
Raphael, how's everything looking? What's being discussed down there?
Hi, Rob. Well, so far,
Hey,
so good.
sister,
We
thanks.
just received the last weather forecast. It's all green for the H0 that is forecast right
Okay, we're
now.
green.
What we checked was
send it.
altitude winds, wind in the vicinity of the launch pad, and risk of lightning. So right now, it's a relief because the weather was a bit tough
Yeah, sure,
in the
Kyron,
last
that's fine.
couple of days. But right now, everybody is very focused on the next steps. The start of the synchronized sequence at 7 minutes before liftoff. Last operations that Luce
is
described
happening.
earlier before
Let's do this.
Webb and the Ariane 5 are going to lift off and soar into the
Thanks
sky.
for all the subs, guys. Merry Christmas,
Thanks,
everybody.
Raphael. We'll be back with you and Luce here shortly. We now have confirmation from Baltimore that James Webb is on internal
Stereo,
power.
nice.
Amidst all of this
Greg, what's
activity,
going
we
on,
cannot forget that it is Christmas Day. 53 years ago, the astronauts of Apollo 8 completed their 10th and final orbit of the moon after reading from the book of Genesis
proof
on
is in the
Christmas
pudding.
Eve to billions
I
of
tell you,
people
what are you
watching
doing?
with rapt attention back on our planet. The astronauts then headed for home,
What?
following their spacecraft's trans-Earth injection burn. Today, more than a half-century later, we're just minutes away from another
need that.
Genesis,
2
the
seconds.
Genesis of new era of discovery. The launch of the
Eternal
James Webb
audience
Space
for
Telescope
stupid.
is at hand. We're just 38 seconds away from entering the critical synchronized sequence. You're going to be
That was more
hearing
than 2 seconds.
all the critical calls from the DDO, the Range
Hey,
Operations
Dave, get the
Manager,
10 subs. Thanks,
who is
man.
Jean-Luc Voyer, here in the in the Mission Control Center.
Jean-Luc
There he is.
Picard Novaire.
He will be calling the start of synchronized sequence,
Am I right?
all of the critical countdown milestones, and we will be listening very intently for his calls. Let's stand by.
À tous de DDO.
Sorry.
Attention pour la séquence finale lanceur.
Stand by for the final count.
Top. À 0 moins 7 minutes.
Top.
Discovery, go at throttle up.
7 minutes.
And with that, we've entered the period of synchronized sequence. You heard Luce Fabregat just a moment or two ago explain some of the critical activities. The first one coming up
There we
just
go,
a few
Bruce.
seconds from now, which will be the topping off
Whoa.
of the main stage tanks. The
Guys.
first or core stage was loaded earlier
Okay.
this morning with
Thank you for all the
175
subs. I
tons of
appreciate
propellant,
it.
150 tons of liquid
One heck of a Christmas
oxygen, and 25 tons of liquid hydrogen. The upper stage loaded with 15 tons of propellant. That will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude of about 864 statute miles. To put that into perspective, some 520 miles higher than the Hubble Space Telescope and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical, halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
Oh, where's Webb? Cool.
1 minute from now, we will see the 4 tanks pressurized at their flight level for the last test before the ignition of the Vulcan engine. And in parallel, the electric systems are also set in flight configuration on board computer. The electrical power, as for the telescope, it will switch from ground to internal power 1 minute before the launch, 1 minute and 5 seconds before the launch. And we are going to see -6 seconds. At -6 seconds, we will see the disconnection of the upper stage, this big cryogenic arc you can see on this picture.
Okay.
Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence ignites the Vulcan engine of the main stage will start.
Bike a ride.
Will take
welcome to Mission
7
Control.
seconds,
You're going throttle
less
up.
than 7 seconds, where the engine will start up to its flight regime. Once the computer has checked that the Vulcan engine is running normally,
If they start spamming it bad,
you will see at that point a flame going stable at the
I'll be
outlet
like,
of the
no,
nozzle.
Mikey, no.
And at that point, the onboard computer will ignite the 2 boosters that will enable to move the 770 tons of Ariane and Webb.
Coming up on the T-minus 4 minute mark right now. Just a couple of milestones real quick. At the 1 minute 5 second mark into the flight, Ariane 5 will go through the period of maximum dynamic pressure.
It goes up.
Max Q as it's known. That will be the period of maximum aerodynamic forces on the rocket itself. The solid rocket boosters, which will provide about 90% of the initial thrust off the launch pad, will shut down and separate at the 2 minute 21 second mark into the flight, followed 1 minute and 5 seconds after that by fairing jettison. That will expose the James Webb Space Telescope to the environment
is indeed
of flight
good,
for the
Einstein.
first
Yes,
time.
we need it to go
the main
up.
stage separation, or the first stage
Up,
separation, comes
to the right,
at the
not back
T-minus
into the
at
left.
the 8 minute 47 second mark into the flight. And that will be about a 16-minute burn of that upper stage engine.
No, not that one.
It
Not
will
back to
cut
the left.
off at about 24 minutes, 51 seconds into the flight. And then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2 minute 50 second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer.
Gradient, 47.
The weather is go.
Right,
we have a green board. No issues being worked.
There's Greg.
NASA officials, including Greg Robinson on the right, carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation
can do this,
of the James Webb Space
the Europeans'
Telescope that is
contribution.
about to fly.
Their contribution is the launch.
Romero on his side, on the left of the screen, from Ariane Space.
All right, 2 minutes.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2 minute mark in the countdown.
The flight will be in 2 phases. You will see the first part of the flight during the solid rocket boosters phase. That will be the atmospheric part of the flight. The atmospheric flight
Where's James
and
Webb
the
built?
trajectory will be driven by
In the U.S.
very,
Northrop Grumman
to
made it.
reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited
They're
guests
getting ready
moving
to
out
go.
to the observation platform that is right next to the Jupiter Control Center.
They're going
as we
outside.
stand by for the
to go
1-minute call
watch
from
the launch.
Jean-Luc Voyer.
À tous de DDO, attention pour moins 1 minute.
Stand by for T-minus 1 minute.
Top, à 0 moins 1 minute.
Top.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now. T-minus 50 seconds and counting.
T.
As you heard earlier, the Vulcan 2 engine will ignite.
Goodness.
Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way.
50 pack, man. He brought the keg. Squared. Thanks, buddy. All right.
T-minus 30 seconds and counting.
Alerters are going off, dude. All right. Let's go.
Standing by
20
for terminal
seconds.
count.
À tous de DDO, attention pour les décomptes finales. 10,
Stand by for the final count.
8, 7, 6, 5,
Umbilical sap.
4, 3, 2, unité, top.
Okay, Vulcan ignition.
And
That looks
engine
good.
start.
Stand by T+6.
And liftoff.
She's flying. Here we go.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
He's flying.
Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Looks good. Everything looks all right there.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion.
Okay. Yeah.
The rumble of the
Really
powerful
moving on.
Ariane 5 now being felt here in the control center. 3D
Taco with
animation.
50 subs, man. Damn.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about
I'm going to move the
0.6
webcam
kilometers
over there,
per
guys.
second.
Tous les paramètres à bord sont normaux.
So we can see the telemetry.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly
There we go.
overlaid over the green line, which was the
So
pre-launch
over there,
trajectory.
left side of the screen, that's the live
1
telemetry.
minute,
That's
41
not-
seconds into the
We
flight,
have an animation
about
in the,
40
in the center,
seconds
but
away from
this stuff down here,
shutdown of the solid
that's
rocket
the real
boosters.
telemetry. What does vitesse mean? Velocity.
Coming up on the 2-minute
So
mark into the
altitude,
flight.
distance, and velocity is what we have.
When it detects the threshold on acceleration, not the deceleration, but
Yeah, me too,
less
Dutch guy.
acceleration for
Tous les
the,
paramètres à bord
We'd
sont
get some
normaux.
on boards.
everything is okay.
Okay, coming up on
Everything is
SRB
normal.
separation.
2 minutes, 15 seconds into the
Separation
flight.
EFP.
When the computer detects this threshold, it will separate.
Séparation des EAP.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about 1 minute, 5 seconds to go before fairing jettison. That'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as
Yeah,
the
the
launcher
pitch up's normal, guys.
leaves the atmosphere, as is now the
Go and
case,
throttle up.
the satellite does not
Mark Z.
need anymore to be protected, and Webb does not need anymore to be
Paramètres à bord
protected.
sont normaux.
So each kilogram being very important for the performance of the launch, we are going to eject
Okay, we're coming
this
up on
no more
separation.
useful
Quaff.
fairing.
Or fairing separation here.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Ariane Space. Raphael, so far so good.
Hi, Rob. So far, so good. Everything is nominal.
Okay.
As, we say when attitude and trajectory of the Ariane 5 is going perfectly well.
Right.
As you can see also on the yellow line on the screen, we had the confirmation of the separation of the two solid boosters and now of the flaring, meaning that we have crossed the limits of the atmosphere. So everything is going super good. And the video just said
Ariane's
that
a good
all
rocket,
parameters
man.
are
Very,
going
very capable for what it is.
smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings, basically, and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
That's nuts.
Le trajectoire est nominal.
Trajectory is nominal. The report from Jean-Luc Voyer.
Rob, I just said that. Jeez. 20 years in the making,
The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time.
Crazy.
9:20 a.m. Peru time, 7:20 a.m. Eastern Time.
Go.
The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
5 minutes, 12 seconds into the flight.
I know what you mean.
We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line.
It belongs to the universe.
Meaning, we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
All right, see the X that's over there, the yellow X, and the circle around it? If the X is in the circle, that means we're good. If the X goes out of the circle, that means we're not good.
It will track the launcher up to the ignition of its upper stage. And then we have the Navies station in Brazil, Ascension as you can see on the map, in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, you can see that the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Tantal on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system.
So we can just warp
moves further and further out into deep space. All of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned. And just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit.
Discovery, go at throttle up.
This is fine. There.
About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope.
Discovery,
about 30 seconds away from main engine cutoff.
Yeah.
Discovery, go at throttle up.
Jean-Luc Voyager.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Boyer, as we stand by for main engine shutdown and separation.
Okay.
Discovery,
Here we go.
go at throttle up.
Core stage shutdown.
Extinction de l'EPC.
Discovery, go at throttle up.
Opération EPC.
Perfect. We have main stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer
Core stage
orbit,
is
and
still
right now
suborbital.
everything is again nominal.
7,600 velocity is orbital, guys. So yeah, no, that stage will come back down.
From now, the so-called sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating, Luce.
Exactly, Rob, like a baby in a cradle. You can see here Webb attached on top of Ariane 5 upper stage with a very specific configuration. Of course, it will be different during its lifetime, but for the time being, its sun shield is 40.
Why is the second stage a one and done ignition? That's all you need.
A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun.
It has to do with the thrust-to-weight ratio on the second stage. It's got a very low thrust-to-weight ratio, which means it's not making a lot of thrust. It's pretty heavy. But where lacks in thrust-to-weight makes up for in delta V. It has way more delta V than any upper stage of that size. So they do sink a little bit, but it'll go right back up. Long story short, orbital mechanics.
To maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion,
necessarily dreaming. It's just
coming up
low
on the 12-minute mark
ratio
into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Peru. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed, but we're not stopping there. It's going to go all the way to the transfer orbit. 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the Mission Operations Manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then a 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control,
pretty international effort, Europeans,
preventing
Americans,
water
Canadians.
ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. We're 13 minutes, 55 seconds into the flight. Jean-Luc Voyer, the range operations manager, continues to report a nominal performance for James Webb. And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope
I have no clue, Kaiser.
on a highly elliptic
it's going to be
orbit,
up there for a
but
pretty good
still
while,
around
though.
the Earth. The telescope will be released, inserted on an orbit around the Earth, with an apogee, a very high apogee above 1 million kilometers.
Trajectory nominal as reported by Jean-Luc Voyer. You see him in that view, 185 kilometers in altitude, some 4,500 kilometers downrange from the launch site here in Kourou, moving at more than 8 kilometers per second. Right on the plot, right on the trajectory, everything looking great. We are about 9 minutes away from the completion of upper stage
the last
ignition.
6 years. Thanks, Jeff.
It's shut down, and then about a 2.5 minute coast phase before Webb will separate. Observatory separation will be called out. You'll be hearing those calls and the initial calls from Carl Starr, the mission operations manager at the Space Telescope Science Institute at Johns Hopkins, through solar array deploy and the declaration of a power-positive spacecraft. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical, halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour. We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas day.
Yeah, it's going on the other side of the moon, Casbin. Well, it's not entirely true.
The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in kilometers per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early phase operations and the commissioning of the telescope.
This is going to a Lagrangian point.
The
Earth solar Lagrangian point 2.
Orbit and
it's a neutral point in gravity
between
celestial bodies.
And of course, even though we're still in powered flight,
hard to explain
the trajectory, the acceleration, the speed at which James Webb is going towards its preliminary orbit,
it's a long way away.
all modeled in advance. in
it
advance
uses the
and
Earth to block
carefully
out the sun with the sun
choreographed to
shield.
maintain as quiescent an
Combined with
atmosphere
the
and
sun shield.
environment around the telescope for its ultimate separation from the upper stage of the Ariane 5 rocket, which is about...
Like, if you picture like a camera going off, right? You have the camera lens, and then you have a flasher, right? The flasher shines the light, and you see what you need to see, right? It's backlighting the camera. The way that James Webb is placed, it's always facing away from the sun. So it's using the sun as a backlight, so to speak. It doesn't work exactly like that because it's infrared, but that's the idea. You're not gonna get the sun screwing up the picture because it's behind you, just like the flasher on a camera.
And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight
for a long time.
About 5.5 minutes from now.
Night, Midge. What's the graph on the bottom? Ground track is the first one. Second one is telemetry.
As you
that
said,
shows altitude,
we will have a short
downrange
ballistic
distance,
phase, a short coasting phase that will, when the upper
Yeah.
stage will rely
Yeah.
fully on its
altitude, downrange
attitude
distance.
and roll control
Then
system.
the one on the
And
far
it
left
will
is altitude, distance, and
adjust
velocity.
its attitude so that during this small ballistic phase, all the requirements from the telescope are fully met. And that at the separation, there will be the separation. The conditions will be very smooth and as requested for the telescope. Beginning of life.
Today's countdown was as flawless as you can imagine. The weather was perfect
It's not
all the way
designed to
through
have
the
anything
early
docked
morning
to it,
hours,
Talon, so
through
probably
the
unlikely.
fueling process of the vehicle. The weather's been a bit dicey here in Peru over the past few days.
Yeah, Carl,
Everything
you'll be
fell
fine.
together
Holy
on this Christmas
crap.
day to send a new present to the world's
It's a
astronomer.
pretty good Christmas present.
20 minutes, 40 seconds into the flight.
Jeez.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager.
Snap. You didn't need to do that, dude. Appreciate it, though.
4 minutes of powered
That's
flight
too good to
remaining.
me, man. Okay, everything's looking good here. I don't see any. The telltale signs, like in mission control, is looking for people doing this.
Levrone tracking station.
If something is going wrong,
Wrong.
they do this or this, or they make the not like this
nominal,
emote
the
face.
trajectory is fully normal,
But
fully as
everything looks good
expected,
here.
as you can see on
There
the
is,
on the
in
plot
fact, no face
with the
touching.
red, with the yellow plot over the green one. That is the expected one.
22 minutes into the flight.
How long are you going to stay on? Dude.
Less than 3 minutes of powered
When they
flight
do
remaining.
satellite separation, I'm out. It's Christmas,
flight
man.
control.
We got a little bit of.
And again, as we've mentioned
it's just adjusting
before,
fast, we're good.
everything nominal reported by the range operations manager. As we've mentioned before, this is a long ride uphill for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by the Malindi station.
That's right, Miller.
As expected for the end of the flight and the last part of the upper stage flight.
It's going to take
and the
a
separation
month to
of the
get out there,
telescope.
guys. It's going to coast.
James
It's
Webb
a
is
long
about
way
4
away.
minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore.
What's the drink of choice? Oh, you know, I mean, we're in Michigan, so
1 minute of powered flight remaining.
I'm waking up with some orange Faygo.
The upper stage continues to function perfectly. It's been a smooth ride
launch
for the James Webb Space Telescope.
Trajectoire nominale.
Trajectory is good. It's basically orange juice. Yeah, basically, it's fine. It's fine. Basically orange juice.
The upper stage was loaded
pre-flight
this morning with 15 tons of propellant for this long 16-minute burn.
Thanks, man.
Now about 30 seconds away from upper stage cutoff.
It's Christmas, man. Yeah, this is Detroit orange juice. It's very important to understand that.
And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Merry Christmas in Fort Wayne. All right, right back at you from Dearborn, man.
Extinction JWST.
Okay.
Tous les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected. With the exactly
stage shutdown,
expected altitude and speed and velocity.
Whoop, goalie.
So now we have entered the coasting phase, the ballistic phase that will last for a little more than 2 minutes.
Okay, this coast shouldn't take very long, guys.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute, 7-second mark here into the flight.
Binding of Emily. Welcome to Mission Control. You're going throttle
Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5.
Yeah, it's not a long coast period.
As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
9.71 kilometers a second, but it should be decelerating because we're eccentric.
Some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards the liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
Yeah, we're not doing 30-day marathon streams.
And we're about 17 seconds away from Webb separation.
But no. Okay. Coming up on SEP. Let's listen for the call. Listen. Oh.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery.
Holy crap.
It was a perfect ride to orbit.
Pretty good Christmas present.
And
for
all
everyone
of the
else,
sequence events are running in good
really
fashion,
good
according to
Saturday
the telescope controllers.
Oh, there's live views. Look. Oh,
And there is the view from the upper stage camera on the Ariane 5 looking at the James Webb Space Telescope as it moves gently away from its launch vehicle.
Yeah, all right. That's awesome.
Pictures of this telescope.
Go Webb, go Webb.
Yes, go Webb.
Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive.
That's wild, huh?
Pictures. Yeah.
Now we'll be hearing shortly from the Mission Operations Manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array.
Oh, my goodness. Look at the solar array. There it goes.
And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Ariane Spas.
Pretty cog. It's pretty cog.
And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive.
Hey, Rob. J'entends pas ce qu'il me dit. Il m'a appelé ou pas?
Oh my goodness. We saw it deploy. We saw it deployed solar panel. Oh, that's so
And there
cool.
it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Ariane Spas.
This is it. We have witnessed and the confirmation that Ariane 5 has safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the sun.
Hawaiian t-shirt
honestly,
day.
I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Ariane Space, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the
James
team
Webb's
in the
control
flight.
room.
Really, there is no words to describe the immersion that is happening right now in the fishbowl.
I don't see any of this.
All I can
So
say
everything
is
looks
good
good.
luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations.
They never to see them smile.
Luce Fabricate, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insight throughout the course of the day.
That means it was a big deal.
And really a great achievement. I have many faces and names now
The
coming
Europeans
up to
never
my
smile.
mind, and
Not,
really you can be proud of what was achieved on both
we do not show
sides of the
emotion.
Atlantic
That is very
Ocean.
unprofessional.
Thanks a lot to you.
Tremendous jubilation here in the control center. You're looking at Jean-Luc Boyer, the range operations manager.
That's cool.
Quite a Christmas present for the world's astronomers as the James Webb Space Telescope begins its life heading towards deep space. With that, we're going to go back to the floor now to Katie Haswell. Katie, we did our thing.
Amazing.
It's up to you now.
And Katie's back.
Oh, my goodness.
Katie's the best.
I just can't tell you. It's such utter jubilation here on the floor in the Jupiter Control Center. Everybody's whooping with joy. The controllers here and the mission controllers jumping up, clapping, whooping with joy, people hugging. And I have to say,
it's very strange.
My throat was caught as I
Very
saw
weird.
the glimpse of sunshine on Webb solar panels as we watched it heading out into space on its journey to its working zone. It's going to take about 6 months before we start getting our deep space observations from where,
Close to it,
of course,
Sib.
the teams have got a huge amount to do before we get to that. And our best wishes with all those teams in Baltimore. I want to get some reaction. Right now, everybody's talking and hugging each other because they're feeling so excited, and I totally understand that. Let's start, though,
That must
by
feel
going
like $1 million
over
bucks
to
right now.
NASA administrator,
Oh, I'm sorry, $1 million
Bill
euros.
Nelson.
Not sure, Just Face. They're saying something about power. It's some power calls or something. Someone I couldn't get it. What's that, Brim?
Okay.
Oh, Mr. Puddin's coming. Oh boy, guys, the Puddin man is going to
Administrator
come on
Bill
the
Nelson,
screen.
right now, looking at these jubilant scenes here in the Mission Control Center
That's
in
Greg.
Kourou,
Greg.
the European spaceport
No,
in
no, not
South
him, Jonas.
America.
Somebody else.
There are the teams. The mission controllers have
No,
done
Digital
a
Zeros.
fantastic job. It was
Jeff
an
Bezos
utterly
is the
flawless
most
launch.
expensive payload ever launched.
From the European spaceport here on the
That's true.
equator in the Amazon rainforest. Hoping to go over now to NASA.
He's bringing the proof
Administrator
access.
Bill Nelson to get some reaction from him.
True.
All stations, 7.5 minutes. Until the sequence continues with our ADIR release part 1.
I mean, this one is pretty expensive. It's pretty up there, but it's not. It's not that. Oh, be quiet, Sick. There's suborbital payloads.
GSC on off, filling the JWST config.
Oh, bad. Bad taco. Yeah, I think so, Marcia. Yeah, this is probably in terms of like a satellite and not a person. This one is definitely up there. I love that they have Christmas hats on. It's amazing. Hey, Archie, you too. Wait. Feliz Natal. Pretty awesome. These guys, that's cool.
The range operations manager has been calling out the
I like it, Just
milestones
Face.
throughout the flight today. And the ESA teams responsible for so much fabulous work. Great teamwork here to get the Webb telescope into space, and Webb is now heading out on its journey on its own with the mission controllers, the telescope mission controllers in Baltimore, following those incredibly important first actions and first operations.
Oh, dude, such a
Charlotte
relief.
Bezko there, who's responsible for the ESA operations here
very happy
at
right
the
now.
spaceport. We're hanging in
That's a
there,
pretty
waiting
good-
and hoping
pretty good
to
present,
hear
man.
from the NASA administrator, Bill Nelson, who I have absolutely no doubt
Are you
will
wearing
be
khaki
as
pants in
jubilant as
solidarity?
everybody here at the
No.
Young Space Center.
I got my NASA shorts on. With
Charlotte
space
Bezko.
shuttles.
At 13:04, we're expecting Andy
Who has been working for, I think, most of her professional life in human spaceflight, and now heading up
Why
the ESA
Baltimore of all
operations
places?
here at the European
That's
Spaceport.
where the Goddard Space Flight Center is. It's kind of important. NASA's headquarters is here. I know, of course, right? It's pretty cool. More or less stressed than mission mode. Oh no, I'm not launching, man. I'm just along for the ride. This is way less stressed than mission mode.
Over to you, Bill Nelson.
Oh, here we go.
Okay, Katie, thank you very much. This is a great day, not only for America, for our European and Canadian partners, but it's a great day for planet Earth. Thanks to the team. You all have just been incredible. And over 3 decades, you've produced
Because it's not just me,
telescope
right? The audio.
that is now going to take us back in time. It's a time machine. It's going to take us back to the very beginnings of the universe. We are going to discover incredible things that we never imagined. And isn't that typical of this team, where the impossible comes possible? I can't thank you enough on behalf of a grateful United States government. I can't thank our partners in Europe and Canada enough. The French launch team, the Ariane Space, the flawless perfection of the vehicle. And now we have to realize there are still innumerable things that have to work, and they have to work perfectly. 344 of them. But we know that in great reward, there is great risk. And that's what this business is all about. And that's why we dare to explore.
You said that backwards.
The James Webb Space Telescope is very much a part of that exploration. It's significant that we had the delays, and it kept us all the way to today, Christmas Day.
Still works. Yeah, it's good
when
enough.
Others long ago peered up into the sky and saw stars. But it's also another millennia before that a shepherd grazing his sheep would look up at the night sky.
True that, Mutter.
He became a poet. And he penned the words,
Discovery, go at throttle up.
"The heavens declare the glory of God. The firmament shows his handiwork." That shepherd, that poet, became king. And those immortal words in Psalm 19 encapsulate the expressions that we have today. The handiwork of God as we peer back in time over 13 billion years ago, capture the light from the very beginning of the creation.
Discovery, go at throttle up.
My congratulations to the team. My congratulations to NASA, to our partners.
Is this man here to give
Go
us our
James
Christmas
Webb
pudding?
Space Telescope.
That's all I had. That was
God
my
bless
joke. It
you,
was Christmas pudding.
and God bless planet Earth.
Merry Christmas, Bill.
Back to you, Katie.
All right.
Bill Nelson, thank you very... Bill
All right.
Nelson, thank you very, very much for those incredibly moving words. Indeed. We're heading out to look at the first light of the universe.
That was classy. I like
Bill
that.
Nelson there. We
That was
have
good.
Stefan Israel with us from Ariane Space. Bill Nelson there being so complimentary about the partnerships, the teamwork,
right?
and thanks as well to you guys for this fantastic launch. What a day, Stefan.
Indeed, what a Christmas gift today from the Guyana Space Center. We really want to thank NASA for its trust. The administrator, Bill Nelson, we have with us Thomas Zoboron and all his team, and our first thoughts are going to NASA. It is a journey of 20 years we have made together. We have worked as hell, I would say, to make this happen, and now it's done. I want to thank as well ESA, who is formerly our contractor for this launch. We have Joseph Ashbarer with us, we have Daniel Neuenschwander. We have worked hand by hand to make it happen. I want to thank CNES, Ariane 5 Design Authority, and our daily partner here in the Guyana Space Center. Philippe Baptiste is with us, Marianne Claire is with us. Thank you very much to CNES. For sure, I want to pay my tribute to Ariane Group, which is the prime contractor of Ariane 5, main shareholder of Ariane Space, and which has delivered the launcher up to liftoff. And doing so, I pay also my tribute to Ariane Space team.
I agree, W.
The Ariane Space team have worked all this year to make this 14th launch of the year and this very special mission. Your dedication, your professionalism has made the success of tonight. Tonight is a great step for the space journey. It is also a great step for the friendship between the United States of America, Europe and France. So thank you very much to all of us. And now I think we can take a little bit of a rest, but we are going now to leave with Webb up to its final destination to the Lagrangian point. Thank you very much. Thanks a lot.
Why did they choose the Europeans? Because they paid for the launch vehicle. That was their contribution to James Webb.
The European Space Agency is Joseph Ashbacher. Joseph.
So Merry Christmas to everyone. And we have delivered a Christmas gift today to humanity, to people, to NASA, but also to all the people in this world. Because with this James Webb Space Telescope, we are really enabling new science, new excitement, but also really rewarding all the engineering and all the effort that has gone into it. And I'm really grateful for this success. We have delivered a mission into space.
You guys did a good job.
Positive, everything is nominal, and I'm very grateful to Ariane Space and all our partners for all this work. Stefan Israel has already thanked all our partners, but let me also just very briefly recall that this was really a team effort. It was a team effort of the European team. We call it Team Europe, the European Space Agency, obviously providing the launcher with Ariane Space, with CNES, with Ariane Group, with all our partners which we have to make this possible. And I really would like to spend a minute to thank all the people involved in this. Today is Christmas. Some of them are here, have been spent weeks here in French Guiana or at the sites where they have been working. It's a special moment. I know I have made sacrifices, but it's a special moment, and really thank you from my heart. But also thank you, NASA. Bill Nelson was speaking before. Thomas Zoboron is here with his team. Fantastic cooperation, and this cooperation between NASA and European team is really exemplary. And a big, big thank you, Thomas, and your people for what you have done together with us, that you have entrusted this precious spacecraft to us, which we could deliver. And I'm so happy today, I can tell you, this is a very special moment. It's very nerve-wracking. I couldn't do launches every single day. This would not be good for my life expectancy, but I can tell you this was very exciting, very nerve-wracking, but really, really very successful. And thank you from my side. And congratulations, NASA, congratulations, science community. Big science is to come, and really, really happy. Thank you from my side.
That guy who runs the ESA.
So the president of the CNES, which is the French space agency, is Philippe Baptiste, and he joins us now. Philippe.
Thank you very much. Well, as everybody here in the room, I'm very, very happy to see that everything was fine, everything is nominal. It's great news for NASA, for ESA, for all of us. I just want to thank all the people who have been working over the last 20 years on this incredible instrument, on this telescope, but also people who have been working on the launch. I'm thinking especially of the 500 people who have been working yesterday during Christmas Eve to prepare the launch, to prepare the successful launch, and I really want to thank them very much. People from CNES, from ESA, from NASA, from Ariane Espace, and from all the partners who are around. I also want to give a special thank to the French Armed Force of Guyana who made this launch possible. They were monitoring everything, and without them, nothing would be possible here on this site. So thank you very much for all of them, and thanks also to all people from Guyana who are supporting this incredible European spaceport that we have here today. Thank you very much.
Thank you, Philippe.
Merci beaucoup.
So we now have a pre-recorded message from Lisa Campbell, who is the president of the Canadian Space Agency.
I am so proud to witness the highly anticipated launch of this extraordinary mission. Je suis très heureuse et fière de m'adresser à vous aujourd'hui. It's a remarkable feat of international collaboration to think of all the scientific and engineering coordination that made today's events possible.
Took another car. No.
In fact, Webb is the result of close to 25 years of planning and development with our international partners. Notre participation au télescope Webb est l'aboutissement de plus de 25 ans de planification et développement avec nos partenaires internationaux. We're playing a big role on the world stage. Canadian excellence has helped make this flagship telescope a reality. Our participation in Webb is extremely significant. It's the largest space science project in the 60-year history of our space program. Webb est effectivement le plus grand projet de sciences spatiales dans lequel nous avons été impliqués depuis le début de notre programme spatial. The successful launch of this groundbreaking telescope bolsters humanity's quest for knowledge of the cosmos and ignites interest in astronomy for a new generation. The Canadian Space Agency is proud to have contributed critical instruments to this large-scale partnership as part of a global effort to spur the next great scientific leap. We're thrilled to take part in a mission of such enormous scientific promise. Nous sommes ravis de faire partie de cette mission extraordinaire. Canadian astronomers are excited to use Webb's data and benefit from the tremendous science opportunities offered by this one-of-a-kind observatory. We congratulate the fantastic team of over 10,000 people who put all their skills, ingenuity, and effort into developing the telescope for more than 2 decades. Bon voyage, Webb! Canadians will follow your journey with great interest.
And it's a good day for Canada.
And now
and
I'd like
the world.
to hand you over to Thomas Zurbuchen, who is the head of science at NASA.
This is just an absolutely monumental achievement.
Well, Katie, what an emotional day. What an emotional time. We're here, all of us who have been working together for so many weeks, months, and years, and more importantly, our teams who are taking team images behind us, who have put in front of their lives as the highest priority for so many of them to actually get this done and get it done here, working even during the holiday times. I just couldn't be more grateful to the many, whether it's Ariane Space, CNES, the European Space Agency, all the amazing people around French Guiana, the forces that are here, all the good people that have been such great hosts to our teams, all of them I want to thank. You know, whenever we look at launches, they're both an ending and a beginning. They're an ending of an engineering project on the ground.
Thanks, Dion.
And with many amazing hours and challenges that are there, but they're a beginning. They're a beginning of one of the most amazing missions that humanity has conceived. And I'm so excited to look forward to the next setup of this telescope and all the science to come. Thanks to everybody. This is what we can do when we come together, KDS1 humans. It's just absolutely incredible.
It's wonderful. And Dr. Z, thank you very much. Massive congratulations to you all, to everybody who's involved in today. Huge congratulations from everybody here at the Guyana Space Center, and also our very best wishes to all the teams in Baltimore who are now monitoring those early operations of the telescope as it starts to unfold. I'm going to hand you back now to Goddard, but before I do, I just want to say from all of us here at the Guyana Space Center, Merry Christmas. Over to you, Michelle.
Thanks, Katie.
Thank you, Katie. I can tell you that here it feels like the dawn of a new age. Historians of the future will divide our understanding of the cosmos into eras before Webb and after Webb. Webb is this milestone that marks a bold effort to look backwards in time to the mysterious origins of everything. Of course, we move at human timescales, so here's what's coming up. In the next few weeks, engineers will unfold Webb's critical sun shield to begin chilling the telescope to unimaginably cold temperatures. They'll extend the DTA, the Deployable Tower Assembly, the structure that supports the Great Golden Mirror. And then finally, they'll unfold that mirror and begin the process of fine-tuning the system for work. Through it all, we intend to bring you live coverage of all of the important events that are happening, along with expert commentary and extraordinary images from the Mission Operations Center and our own broadcast headquarters here at Webb's home, the NASA Goddard Space Flight Center. Stay with us over the next few weeks because the adventure is just getting started. Speaking for everyone on the team, it's been a great pleasure to be with you here today. I'm Michelle Thaller, and you've been watching special live coverage of the historic launch of the James Webb Space Telescope. Thank you for joining us.
Well, that didn't suck. That was pretty good. Yeah. Yeah, that was pretty good. Incoming raid. Oh geez. So, well, if you're here, you just missed it. James Webb did launch. It's coasting out. It's going to take 29 days to get out to Earth, Sun, L2. It's going to take a little bit of time. And I'll, if you watch the channel, I'll give you guys the updates whenever I can. So, Asteroids, hey, thank you. Thank you very much. So, launch is a big part, but we're not totally out of the woods just yet. So,
Discovery, go and throttle up.
Hey, Kinhook, thanks for the raid and the subscription, man. I appreciate it. So, in just 3 days, it flies past the moon. Yeah, it's going pretty quick. Merry Christmas. Yeah, you too, Gabe.
Discovery,
Merry Christmas, everybody. That was one heck of a Christmas present, but we ain't out of the woods. We've still got a lot to do. Flight Sim, hey, I just want to say thanks for the coverage. There's no other community space nerds I'd rather watch a momentous occasion with. Thank you. Thanks, guys. You guys are too good to me. You're too good to me. Yeah, you too, Jim. You too, buddy. Thanks for all the subs today, too, guys. I really, really appreciate it. I would have a webcam big scene, but I didn't have time because I was trying to fix the audio. I know that the audio is terrible because I have a Discord call piped into this computer because this computer went DOA on all microphones, which is just a thing that exists. Here, let's just, no, there we go. Pause it right there. I like that graphic. That graphic is cool. But anyway. Hey, App State, thanks for the bits. Merry Christmas, Stevie. You don't see any desync? I need gopher chucks. All right, guys. Long-time streamer, first-time caller. Yep. So, anyway, I hope you guys enjoyed it. I'm going to go enjoy Christmas morning now. So, I will say good day, good luck, a Merry Christmas, au revoir, and God bless all of you on the good earth. Apollo 8. Proof was in the pudding. Proof was, in fact, in the pudding.
Discovery, go and throttle up.
Yeah, it was... Wait, no, it was tapioca. It had to have been. All right, guys. Thank you very much. I'll see you guys later. Merry Christmas, everybody. I'll be back on Tuesday, okay? See you guys. Thank you.